Thank you. Good evening, and thank you very much for inviting me to speak tonight, and certainly for giving me the very challenging opportunity to discuss molecular inorganic chemistry at 6:30 on Tuesday evening, hopefully with the goal of not putting anyone to sleep. With that, what I'd like to do is to discuss very briefly some of the background information, the kind of what we know, what we don't know, what we think is happening, and what we are doing about it. Certainly, the easy part to say is that what we're dealing with drywall, sheetrock, that was imported from China. It was used and installed anytime between about 2001 to about 2007, but the target, really the focus of it is about 2003, 2007. You got to give a lot of leeway on either end of that. There are reactive compounds in it, and these reactive compounds are causing discoloration and deterioration of metal surfaces, specifically copper, but other types of metal as well within the house. There's also a very strong objectionable odor, not unlike rotten eggs or sulfur-like odor. One of the interesting things that we're finding about this is the ability of the gases that are coming off of this material to go from where the point of origin being the reactive sheetrock, the reactive drywall, into porous surfaces, what I call and what I will be referring to this evening as recipient materials, such as furnishings, clothing, carpeting, or drywall that is not imported or otherwise non-reactive. Something that's been in the news a lot about this is also speculation regarding radioactivity. So far, though, we are of the opinion that that is not an issue. Of course, anything that I'm discussing tonight, that I'm saying that this is what we know about it, is always subject to change because it is kind of a new and evolving field of science. There was an EPA study done a while ago that analyzed, at the molecular level, some of the imported reactive sheetrock versus drywall versus domestic or U.S. drywall. And what they found is that there were some chemical differences. They found, in some cases, some components that were present in the Chinese drywall that were completely absent in the U.S. drywall. And in some cases, they found some components that were present in the Chinese drywall that were also present in the U.S. drywall, but were not present in as high a concentration. So clearly, we are finding some sulfur and organic type compounds that are either absent in U.S. drywall or just not as much of it. There were some studies done of the product, of the copper, the corroded material, to say, okay, well, we see that it's corroding, but what is it turning into? And they're finding various oxides, copper oxide and copper sulfide, present on this material. And we also know that by doing some air studies, that they are finding some airborne chemicals, constituents of concern, specifically carbonyl sulfide and carbon disulfide. However, what we're not exactly sure of is kind of connecting the dots. Well, we know that we have this material that is chemically different if it's coming from China and if it's reactive. It's not to say that all Chinese drywall is reactive, but the stuff that's reactive is coming from China. And we know that it's chemically different than the domestic stuff that's non-reactive. And we kind of have a pretty good understanding of what the off-gassing properties are. But we don't necessarily know what's happening between point A and point C, so to speak. The good news is that for what we're here to talk about tonight, we don't really need to know that. We need to know whether we have the reactive drywall, what's going to happen as a result of having it, and what we're going to do about it. So, having said that, I want to talk a little bit about some of the air samples. There's a tendency when we're faced with an environmental issue to run out and collect samples. A lot of the people that share my profession love to take samples. You get these great laboratory results back. In this case, though, there are a lot of problems with it. First of all, one of the key elements or indicators if you have reactive drywall is the presence of an odor. Well, we can, as humans, can smell sulfur-containing compounds at very, very low concentrations, typically at concentrations below which a laboratory can detect them. So that's very problematic. The second thing is that when we look at the results of the previous studies, and these studies were done probably less than a year ago, right around a year ago, what we're finding is that the constituents of concern are present at very, very low concentrations, usually 1 to 10 to 15 parts per billion, if it's present at all. So it's possible to have a house or a condo with reactive drywall in it. You can go collect very expensive laboratory tests and yet have those tests come back negative. Well, guess what, folks? It still means that you have the reactive drywall. So because of that, the general consensus in the industry now is to shy away from collecting samples. That's not to say that in the future some better fingerprint, some better laboratory analysis may not evolve, and a lot of good labs are working very hard on it. But as it stands right now, laboratory samples are something that just is not that critical.